This will be the last section in Chapter 7, and this is something that's referred to as functionals. A functional is an R word that is used to describe a function that has arguments that are themselves functions. So to give you a simple example of such a situation, let's go with sapply. Now a lot of this is done with the apply function, but there are a lot of basically lookalikes like the apply function. So for example, the one we're looking right now at is sapply, but there is vapply and mapply and all that. You can go out on the web and search on these, but this is just to give you a taste of how these things work. So what I'm going to do is I'm going to take the vector 1 through 4 as my first argument, and my second argument will be the factorial function. And so what this will do is this will apply the factorial function to the integers 1, 2, 3, and 4. And you can see in this case we get 1 factorial, which is 1, 2 factorial, which is 2, 3 factorial, which is 6, and 4 factorial, which is 24. Now in this particular case, there's really not much benefit to that because I could have just typed factorial 1:4, fewer keystrokes, and I get exactly the same thing. But you're going to see how this works on a matrix using the apply function, and here you'll see a little more power of the functionals. So let's set up a matrix X, and let's put in the integers 1 through 12, and let's put them into a 3x4 matrix. So you can see that shows up here in the upper right because we have defined an object, and the name of the object is X. It has 2 subscripts. The first can be a 1 through 3. The second can be a 1 through 4. By typing X, the matrix is displayed. Notice that it is done in column-wise fashion by default, is how the 1 through 12 went in there. Let's set a vector, or I'm sorry, a matrix, or in this case I think it will be a vector. We're going to take the apply function, and we're going to use X as an argument, and then there's this 1. And the 1 says we want to apply this by row, and we can come up with any function that we want, but let's use the mean function. So here's what I have is I'm going to apply this to the matrix X, which is displayed just above here. I am going to calculate the means of the columns. And again, if there is a 1 here, it'll do, if there's a 1 there, it will do rows. If there is a 2 there, it will do columns. So when I do that and look at Y, first thing I get here is a 5.5, and a 5.5 is the average of those 4 numbers. Again, we're getting row means. The 6.5 is the product, or is the mean of these numbers. And the 7.5 is the mean of those numbers. So again, we're finding row means in this case. But we could have also applied, for example, again, with respect to X, we could have found column products in this fashion. In this case, when we look at Z, notice that the product of the 1, 2, and 3, which is the first column, gives us 6. When you take the product of 4, 5, and 6, 4 times 5 is 20. 20 times 6 is 120. When you take the product of 7, 8, and 9, 7 times 8 is 56. And 56 multiplied by 9 is 504. And finally, when you multiply 10, 11, and 12, you get 1,320. This ends Chapter 7. You may want to check the book for a few more examples regarding functions and functionals.